Germicidal light bulbs have been known for over a century to kill germs. When you look at one of these light bulbs, you see a bright violet light. That light that you see is not the light that's killing germs. The light that's killing germs is invisible. That's why they call it ultraviolet. The ultraviolet spectrum is the spectrum of wavelength below 400 nanometers. But included in that spectrum, you have UVA and UVB, which is the sunlight that causes tanning. These wavelengths penetrate the ozone layer and reach the Earth. This part of the ultraviolet spectrum, known as UVC, is of a shorter wavelength yet. Specifically, the germicidal part peaks at 254 and 185. The difference is a light bulb that has a 254 nanometer only will not produce ozone. A UVC lamp or light bulb that peaks at 185 nanometers produces ozone. Now you may wonder, why do you want your UVC bulb to produce ozone? Ozone itself is a gas that has germicidal properties. In addition to the germicidal properties of the 254 nanometer wavelength. So you have a choice. One of the parameters when you buy or shop for these UVC bulbs is the wattage. The wattage, you'll see it rated as 25 watts, 75 watts, almost like standard light bulbs. That power is not the power that's killing the germs, because that power includes all the power that the bulb is using to generate that visible portion that you see as ultraviolet. The power that's actually killing the germs is much, much less, typically in the range of milliwatts or microwatts. Here's an example of a light bulb rated at 8.5 milliwatts per centimeter squared at 1 inch, 4 milliwatts per centimeter squared, 5 inches, and so on. Notice that as the distance increases, the power decreases, as is true of all sources of light. These numbers represent the wattage only in the UVC band, and that's the number that counts. I have a meter that directly measures UVC light. Not UVA, not UVB. They will always show 0 on this meter. And if you were to point this meter at the sun, it would show 0 because there is no UVC light reaching the Earth. But if I were to point this meter, and I did, at a light bulb that I have that's rated as 25 watts, measuring 270 microwatts per centimeter squared. That's the number that shows up on the screen. That's the wattage of the UVC wavelength, specifically 254 nanometers, which is what this measures. This number is the intensity of my light bulb measured at 1 foot. The intensity is one parameter. It's how bright it shines at a given distance. This was at 1 foot. And it's a built-in parameter based on what the bulb can produce. When you're talking about killing germs, you talk about dose. Dose is measured in millijoules per centimeter squared. So we need to know the relationship between dosage and intensity. And that relationship is this. Dosage, or dose, equals intensity times time given in seconds. For the different varieties of coronavirus, the kill dose is given as 40 millijoules per centimeter squared to disinfect 99% of the germs. So given that knowledge, we know the dose. It's 40 millijoules per centimeter squared equals the intensity. The intensity of my light bulb at 1 foot, we know, is 270 microwatts per centimeter squared times time in seconds. What I want to know is how long of an exposure is necessary for this light bulb at this intensity to provide 40 millijoules of energy to kill coronavirus. How many seconds? How much time does it take at this distance? So what we have to do is solve for time. Dosage equals intensity times time, then time equals dose over intensity. We have these two numbers. The dose is 40 millijoules, but I need to simplify things at this point. 40 millijoules, we want to put this into decimal. I want to get rid of the milli and just make it joules. So we have to move the decimal point over 3 places. So this becomes 0.04. Point 0.04. Sorry about that. Getting used to this new software here. 0.04 joules. Joules, though, spelled Joules, or joule, is equal to watts times seconds. So this is 0.04 watts times seconds per centimeter squared equals, now we could also simplify the 270 microwatts, and that would become 0.00027 watts per centimeter squared times seconds. So seconds, time, dose over intensity, is equal to 0.04 watts times seconds per centimeter squared, divided by this number. But when you divide a fraction by a fraction, you can invert the bottom fraction and multiply. This goes on top. This goes on the bottom. Okay. The centimeter squares cancel. The watts cancel. Seconds does not. So we have 0.04 over 0.00027 times the remaining seconds. And if you do that math, it comes out to about 148 seconds. Divide by 60, and that's roughly 2.47 minutes. So what does this mean? It means that using my light bulb to kill coronavirus or any kind of virus, even including the SARS CoV-2 virus that causes COVID-19, at a distance of 1 foot, takes 2.5 minutes. You can work out the numbers for any one of these microorganisms. You could look up specific tables for the microorganism of interest to you and work out the math yourself. But just be aware that when you're buying bulbs, there are two varieties, ozone producing and non-ozone producing. And the wattage that's given, 27 watts, 50 watts, 75 watts, is not the wattage you're concerned about. You're concerned about this wattage over here. And if it's not given, call the manufacturer, say, I want to know what the intensity is at a given distance. Once you know this, then you're on your way to doing your own calculations. Thank you for watching.